You know there are three types of heat transfer: conduction, convection, and radiation. We're going to dive again further into conduction and learn more about how conduction works. We're going to deal with insulators and conductors, like this metal spoon and a conductor, and that wooden spoon, an insulator. First, the word thermal. It relates to heat. For instance, here we have a chemical reaction, and it has a heat source, doesn't it? And something happens, and what causes that to happen is the heat. So we could call this a thermal reaction. It has to do with heat. It's in chemistry, back more in the area of physics. I could take a balloon and put it in a very, very cold room, let's say a freezer even, right? It might be quite small. I moved it out into a hot room, it's going to expand, isn't it? And the reason is temperature and heat. So we could call that thermal expansion. So that's the word thermal. It relates to heat. Now you recall conduction. First, it requires contact, doesn't it? Contact between that flame and that steel bar. I hope you also recall that as the heat is transferred from the flame to the metal bar, steel bar, the steel vibrates, doesn't it? And the heat is transferred through that steel by vibrations. Eventually you could hurt your hand over here, right? So that's how heat is conducted through steel. Turns out that some substances are very good at transmitting heat, some are not. Now metal is a classic example of a substance that is very good at transmitting heat, and here's why. Metals have tightly packed molecules. They're really packed together in a rigid sort of a lattice, and so when one shakes, it transfers vibrations very well to the next. These are called thermal conductors. They conduct heat. Here's your video code. Yeah, metals are the primary thermal conductors we use. Now, a classic substance that does not transmit to heat well is wood. Now, we have here, if I put that heat on here, this would have some burning, but we would have very few vibrations. I show vibrations back here with the metal. I'm not showing any here. There are very few vibrations, which means very little heat is actually transmitted through the wood. Wood has loosely packed molecules. It transfers vibrations very poorly. This is called a thermal insulator. Heat will not pass through it very well. Again, conductors and insulators, thermal conductors, insulators. We have our spoon made of metal. Here we have a red hot bar heating it up, a bar of metal. Heat moves well through a metal spoon. It's a conductor, a thermal conductor. I'm not using wood here, I'm using plastic. There's also an insulator. Heat moves poorly through a plastic spoon. It's an insulator. Wood's one too, right? All right, so that's the definition of thermal insulators and conductors. Let's just, to wrap up, put some substances in the right category here. Yeah, let's move these words, either conductors or thermal insulators. Steel's what? Well, steel's metal. It's a classic conductor, isn't it? Wood, classic insulator. Heat will not go through it very well. Plastic, we saw that one already. That's an insulator, isn't it? What about paper? Yeah, paper is really much like wood, isn't it? Sure, it's a insulator. Copper, that's a metal, right? That is a conductor. Glass does not transmit heat very well. That's why we have it in our windows in our homes. It's not perfect, but it's pretty much it's a pretty good insulator. And water is the last one we can put over here. If you go swimming, you'll get cold, won't you, pretty quickly, because the heat does transfer into the water. So really, if you look at this picture, the vast majority of our conductors are metal, and usually in this course and on the MCAS test, you'll see metal for conductors, like the middle of the wire is metal, right? All right, that's it. We have thermal conductors that do transmit vibrations and thus transmit heat. We have thermal insulators that do not transmit vibrations and do not transmit much heat, and they're called thermal insulators. Bye.